Hello friends, welcome to Edupedia Word videos. Today we'll be learning we'll be dealing with some questions on area of two similar triangles. Friends, in the previous videos we have learnt that if two triangles ABC and PQR are similar, then the ratio of their areas is equal to the square of the ratios of their corresponding sides, that is AB over PQ, BC over QR whole square, and so on. In this video we'll be using this concept to solve some basic questions. The first simple question says, if triangle MNO is similar to triangle TUV such that area of both be 9 cm square and 16 cm square respectively, and MO is 1.5 cm, find TV. Friends, we are given two triangles. Let us construct these triangles. Let us label these triangles as MNO and TUV. Now we are given that triangle MNO is similar to triangle TUV. Secondly, we are given the areas of both the triangles as 9 cm square and 16 cm square respectively, and lastly we are given the length of MO as 1.5 cm. Now friends, since these two triangles are similar, we can say that the ratio of their areas, that is area of triangle MNO over area of triangle TUV, will be equal to the ratio of their corresponding sides squared. Since the two sides involved are MO and we need to find the side TV, and we can say that they are corresponding sides because the order of the triangle involved is MNO and TUV. So MU is corresponding to TV. So the ratio of these areas will be the square of the ratio of their corresponding sides. Now substituting the different values, area of triangle MNO and TUV are 9 and 16 cm square respectively, and MO is 1.5 cm. We need to find TV. This will give us 9 is 3 whole square and 16 is 4 whole square. So we can say 3 by 4 whole square is equal to 1.5 over TV whole square. If we take the under root of this equation 1, we can say that 3 by 4 is equal to 1.5 over TV, which will give us, on cross multiplying, TV is equal to 1.5 into 4 over 3. On cancelling the different terms, we will get TV as 2 centimeters. So in this question the value of TV is 2 centimeters. Let us move on to the second question. The second question says, prove that areas of two congruent triangles are equal. Friends, let us construct two congruent triangles as triangle MNO and triangle TUV. Now we are given that two congruent triangles, that is, according to the given statement, we are given triangle MNO is congruent and not similar to TUV. We know that all the congruent triangles are similar also. By this congruency, if two triangles are congruent, then their corresponding sides will be equal. Now the corresponding sides are MN and TU and NO and UV and MO and TV. Now friends, we know that two congruent triangles are similar also. Therefore, we can say that triangle MNO is similar to triangle TUV. Now, since the triangles are similar, the ratio of their areas will be the ratio of their corresponding sides squared. Let us pick up the corresponding sides as MN and TU, or MO, TV, you can take any of these. If we take MO, then the corresponding side is TV. Now, from this equation, we have MO equal to TV. So we can substitute the value of TV over here. We will get area of triangle MNO over area of triangle TUV as MO over MO whole square. MO will be cancelled by MO because both are one and the same length, and this thus will be equal to 1 square, which means 1. Thus, on cross multiplying, we will get area of triangle MNO is equal to area of triangle TUV into 1, or simply area of triangle MNO is equal to area of triangle TUV. Hence the given statement is proved, that is, if two triangles are congruent, then their areas will be equal. Let us deal with another question. The question says, prove that area of equilateral triangle described on one side of a square is equal to half the area of equilateral triangle described on one of its diagonals. So here goes the solution of this question. We are given a square and one triangle, an equilateral triangle, is described on one of its sides. Now since A, B, C, D is a square, let us assume its side to be S units. Therefore, AB equal to BC equal to CD equal to DA equal to S units. Now since APB is an equilateral triangle according to the given question, therefore equilateral triangle has all of its sides same. Thus AP and PB will be equal to AB, that is S units. Now we have to describe another equilateral triangle on one of its diagonals. Let the diagonal used be AC. So no doubt ABC is also a triangle, but it is not an equilateral triangle because AC, friends, the value of diagonal of a square is under root 2 into one of its sides, that is S. So AC, its length will be under root 2S. Clearly ABC is not an equilateral triangle. So equilateral triangle will be somewhat of the form let AQC be equilateral triangle. Therefore AQ is equal to QC equal to AC, that is under root 2S. We need to find out that area of equilateral triangle of this triangle PAB is equal to half the area of triangle AQC. Thus we need area of triangles of both the triangles. Friends, we know that two equilateral triangles are always similar because figures of the same shape are similar and figures of the same shape and size are congruent. No doubt their sides are different, but both of them have same shape of equilateral triangle. Therefore the triangle PAB will be similar to the triangle QAC. Now since the triangles are similar, the ratio of their areas will be the square of the ratio of corresponding sides. Now let us pick up the side AB in PAB, then the corresponding side in triangle QAC will be AC. Now from this equation, let it be first and this be second. From first and second we can say that AB is S units and AC is under root 2S units. So we get s gets cancelled by s, and we are left with 1 by under root 2 whole square, that is 1 by 2. Thus this ratio is equal to 1 by 2, or we can say area of triangle PAB is equal to area of triangle QAC into 1 by 2. If we look at the figure, PAB was a triangle described on one of the sides, whereas QAC was the triangle described on diagonal. Thus the area of triangle described on one of the sides of a square is equal to half of the area of triangle described on one of the diagonals. Hence the given statement has been proved. Let us have a last question. The question says, in figure PD ratio DQ is given as 1:3, DM is given parallel to QR. We need to find this ratio, that is PDM and QDMR. PDM is a triangle, whereas QDMR is a trapezium, because DM is parallel to QR. So for the solution of this question, first of all, we are given PD ratio DQ as 1:3. In the fractional form, the ratio are written like this. Now friends, first of all, since DM is parallel to QR, therefore by BPT we can say that PD over DQ is equal to PM over MR, because BPT says a parallel line drawn to one of the side divides the other two sides in equal ratio. But from this part, PD over DQ is 1/3, therefore PM over MR also becomes 1/3. Let this be equation 1. Now friends, we need to find area of some two figures. First figure is PDM, whereas second figure is a trapezium. But up till now we just know a relationship between area of two similar triangles. We have one triangle as PDM and other triangle is the complete triangle PQR. So if somehow we are able to prove that these two triangles are similar, our problems can become somewhat easy. So see, we are given the ratio PD and DQ, and we have proved that PD over DQ is equal to PM over MR. But if we look at the two triangles, that is triangle PDM and triangle PQR, then the corresponding sides involved are PD, which is corresponding to PQ, and PM, which is corresponding to PR. But here in these ratios we have just PD and PM. We need PQ and QR. So if we are able to convert this denominator into PQ and PR, then we will be able to solve some amount of this problem. So for conversion, let us reciprocate equation 2, which will give us dq over pd equal to mr over pm. Friends, pd over dq is equal to 1/3. So these two sides are equal to 1/3 numerically. Therefore, on reciprocating The ratio is also reciprocated as 3 by 1 or simply 3. Now add the numerical value 1 on all the sides, that is this left hand side, this middle side and this right hand side. So we get dq over pd plus 1 equal to mr over pm plus 1 equal to 3 over 1 plus 1. Now on taking LCM, we have dq plus pd equal to the LCM pm and mr plus pm, and here it will be. Now friends, dq plus pd, dq and pd when added will give the whole side pq. So we can say pq over pd is the left hand side equal to mr plus pm. This is the side mr and this is the side pm. When they are added, it will give the side pr over pm equal to 3 plus 1 is 4, so we have 4 plus 1. So now we have achieved PD and the corresponding side PQ in one of the ratio and PM and the corresponding side PR in another ratio, and so on. Now if we name this equation as third, now consider the triangles, the complete triangle PQR and the short triangle, the smaller triangle PDM. In both the triangles we have angle P as common. So angle P of first triangle is equal to angle P of the second triangle. Also from the equation 3 we can say that PQ over PD is equal to PR over PM. Thus, by SAS criteria, we can say that triangle PQR is similar to triangle PDM. Since the triangles are similar, the ratio of their areas will be equal to the ratio of their corresponding sides. Thus, we can say that ratio of the area of triangle PQR over the area of triangle PDM will be equal to the ratio of the corresponding sides. Let us use the corresponding side PQ and PD, their square, since the theorem says that the ratio of the area of two similar triangles is equal to the square of the ratio of the corresponding sides. Now from equation 3, PQ over PD is 4 over 1. Thus, by equation 3, we can have area of triangle PQR over area of triangle PDM equal to 4 over 1 whole square. Thus, on simplification, it will give us 16. Or we can say that on cross multiplication, area of triangle PQR is equal to 16 times area of triangle PDM. But friends, in the given question, we need to find area of triangle PDM upon area of QDMR trapezium. Now if we look in the complete figure, we can say that area of PQR triangle is equal to area of triangle PDM plus area of trapezium QDMR. When these two shaded portions are added, they will give the complete area of the triangle PQR, the total triangle. So from this equation, let it be 5, we can substitute area of triangle PQR as 16 times area of triangle PDM. And the right hand side remains the same. So bringing the terms having triangle PDM on one side, that is left hand side, we have 16 times the area of triangle PDM minus area of triangle PDM is equal to area of QDMR. Thus 16 minus 1 is nothing but 15 times the area of triangle PDM is equal to area of QDMR trapezium. Now friends, we need to find PDM over QDMR, their areas. So area of triangle PDM over area of trapezium QDMR on cross multiplication, that is bringing 15 to the denominator of right hand side, we have 1 by 15. Thus the required ratio is 1 over 15. So friends, this was all on some questions on ratio of areas of similar triangles. Thanks friends for watching Edupedia Word videos.